Hello, this is Mr. Weideman, Lafayette High School, our Functions in Trigonometry class, and this is section 4.2, and this is basically dealing with evaluating logarithms, and I want to do a few examples for your homework assignment. Page 465, 1 through 41 odd. There was basically three sections to this homework assignment. I want to work some examples in each section to help you with your homework assignment. All right, let's do number 1 together here, okay? And it says, okay, we want to evaluate this logarithm, or we convert it to exponential form is what we want to do. Everything throughout this homework assignment really depends on one thing, and that is our inverse property between a logarithmic expression and an exponential expression. Okay, so let's start with this. The first thing you want to look at is I got a log base 2, which has a relationship to a 16, and it has a relationship to a 4. Now that's going to come into play. Let's see how this works. All right, the first thing that we're going to do here is we're going to convert this to exponential format. So we're going to rewrite this expression, and we're going to make both sides an exponential expression. So both sides of the equation, we're going to make exponents of base 2. And that matches our log base 2. And we'll see exactly why we do that here in a second. All right, so I'm going to raise both sides to the equation, become an exponent of 2. And now it becomes apparent why we do that. These guys are inverse operations. I have a 2 raised to a log base 2. So those are inverse operations. So this says 2 to the 4th power is equal to 16. And that's what we're doing with that. We change this expression from a logarithm expression to an exponential expression. And indeed, 2 to the 4th power is indeed 16. Okay, let's take a look at some of these other ones. And it's the same thing. This time I'm given a variable in there, but I'm going to do the exact same thing. All right, I am going to pick a base of 9. Why? Because it's a log base 9. And I am going to raise both sides. Okay, I'm going to make the 2 an exponent of 9, and I'm going to make log base 9x an exponent of 9. And here we can see circled in blue, I can use that inverse property. Okay, and then 9 squared is equal to x. All right, so let's do number 3, or at least get number 3 started for you. All right, what's my deal here? All right, log base b. So b is going to be the base for my exponential conversion. So I have b to the 5. That's one side of the equation. I take b and I raise it as a base, and then I make log base b 32 its exponent. All right, and I think you can figure out the next move that's going to go out here. These guys here are going to be inverse operators. So that means this side of the equation just merely equals 32. So we're going to end up with b to the 5th is equal to 32. All right, so that's that set of problems, 1 through 8. Let's look at some examples from the next section. And I'm doing just the opposite. I want to, this is an exponential expression, and I want to convert it to a logarithmic expression. So I'm going to take the log of both sides, but not just any log. I've got a base 2, so my logarithm I want to be a base 2. All right, so I'm going to take a logarithm of the right side of the equation. I'm going to take a logarithm of the left side of the equation. We wisely chose log base 2. So the right-hand side, I can use that inverse operation, and that side just becomes 3. So I converted my exponential expression into a logarithmic expression, and that's really all you need to do. All right, let's set up number 12. And that's going to be very similar to one of your assignments. Now, what's going on here? Well, I've got a exponent on, not exponent, excuse me. I've got a fraction on one side. So what is that going to do? I'm just going to take log base 5 of each side. Again, that inverse operation right here makes this side simplify to -3. And then I've got log base 5 in that fraction 1 over 25 on the other side. And that's it. I've taken my original expression and converted it to a logarithm expression. Okay? And let's do number 11. Let's at least get it set up. Number 11 is going to work exactly like number 12. I'm going to take log base 2 of each side. And then you know what's going to happen next. I'm going to use that inverse property right there. Okay, so that side is going to become just simply -4. And that is going to equal, got to take the logarithm of both sides. So let's get that fixed. I take logarithm of one side. I have to take the logarithm of the other side. So this is going to be log base 2 on this side. This side is just going to simplify to -4. And this other side is going to be log base 2 1/16. And that's your final answer for that. Okay, let's take a look at another problem. And this problem involves radicals. Let's back that up a little bit. All right, so how are we going to address this problem? Okay, before I do anything with this problem, let's take that cube root of 64 and make that's the same thing as 64 to the 1/3 power. All right, so what are we going to do? Our base of our exponential expression is 64. I'm going to take the logarithm of each side, and I'm going to use a log base 64. Do it on one side, do it on the other. Okay, on the left side, we're going to have that inverse operation going on again. And this then is going to be my final answer. And you're done. All right, let's take a look at the last type of problem that we want to work with. Okay, so it says, let's just evaluate this. What does this equal? All right, well, first thing we like to do to kind of make our algebra make more sense is we just say, okay, it's just going to equal y.